Hello viewers, welcome to my channel. In today's lesson, we'll be discussing partial fraction. Now, partial fractions are the fraction used for the decomposition of a rational expression. Let's take note of this. Partial fraction are the fraction used for the decomposition. So we use it to break down or split a rational expression. And this rational expression will come in form of an algebraic fraction. Now let's go further. It says a single algebraic fraction with two or more distinct linear factors. Let's take note of this. A single algebraic fraction with two or more distinct linear factors can be split into a sum of two or more separate fractions with linear denominators. So this is called splitting into partial fraction, as each part of the expression is called a partial fraction. Let's use that information with the examples given below. So it says a single algebraic fraction. This is a single algebraic fraction. This is also a single algebraic fraction. Now it's made mention of with two or more distinct linear factors. Take a look at the denominator below here. It says the denominator contains two linear factors. The second one, the denominator contains three linear factors. So with this definition here, it says a single algebraic fraction with two or more distinct linear factors, meaning it can come in form of two linear factors or three linear factors and above. It can come in form of four linear factors and so on and so forth. Now it says can be split into a sum of two or more separate factors. So it can be split into a sum of two or more separate fractions. So this is two separate fractions, and what we have below is three separate fractions. Now it says it can be split into a sum of two or more separate fractions with linear denominators. If you look at the denominators here, these are linear denominators. Linear, because we have a linear expression here. So that is why we call them the linear denominators. So if you look at the illustration here, it says A and B are constant to be found. So for partial fraction, after splitting our expression into the sum of two expressions or two separate fractions, after splitting them, we have to look for the constants A and B. That's if we have two distinct fractions. Then if we have three linear factors, we'll be looking for A, B, and C. So here, A, B, and C are constant to be found. Above, A and B are constant to be found. Thus, what this illustration is telling us is this. If our question is given in two linear factors, the denominator, that's after we've decomposed them into a partial fraction, the denominator will come in form of the sum of two partial fractions. Now, if our denominator here is given in three linear factors, it will be decomposed to give us the expression as the sum of three partial fractions. Now let's go to the examples and solve the following question given. So in example 1, we'll have 6x minus 2 over x minus 3x plus 1. It says split this expression into a partial fraction. So for me to split this into a partial fraction, the denominator will have to split them into two separate factors. So this becomes x minus 3 plus x plus 1. At the numerator, we'll have our a, and here we'll have our b. So we're looking for the constant a and b. After splitting into a partial fraction, with the denominators given, we'll have to look for the LCM. The LCM of this expression is s minus 3, s plus 1. So we use this LCM to simplify the question above. Now for the left hand side, x minus 3x plus 1 divided by x minus 3x plus 1 is 1. 1 times 6x minus 2 will give us 6x minus 2 equal to, now on the right hand side, x minus 3 bracket s plus 1 divided by s minus 3. So the x minus 3 will cancel s minus 3. We'll be left with s plus 1. A times s plus 1 is a bracket x plus 1. We'll close the bracket plus, on the other side, x minus 3 x plus 1 divided by x plus 1. So x plus 1 will cancel s plus 1. We'll be left with x minus 3. B times x minus 3 will give us b bracket x minus 3. We'll close the bracket. So the next thing we're going to do, we need to look for the constant a and b. And how we'll go about that, we'll be making use of substitution method. In mathematics, the meaning of substitution is to impute a number. That means to remove and replace. So the reason I'm actually using substitution method here is because I need to substitute this x with a value that we eliminate. Eliminate means that will give us 0 to each part. It can either give us 0 to part A or part B. That way, the whole of B or A will be eliminated. So we'll be able to get the other part. To eliminate B, we substitute x as 3. To eliminate b, we substitute s as 3. So we'll have 6 into bracket 3 minus 2 equal to a into bracket 3 plus 1, close the bracket, plus b into bracket 3 minus 3. So 6 times 3 gives us 18 minus 2 equal to a bracket 3 plus 1 gives us 4, close the bracket, plus b into bracket 3 minus 3 gives us 0. 18 minus 2 will have 16 equal to a times 4 will have 4a plus b times 0 will have 0. Now b has been eliminated. So what we'll have left is 16 equal to 4a. We divide through by 4 to get the value of a. 4 here 1, 4 in 16 will have 4 equal to a. So therefore, the value of a is equal to 4. Now move forward to get the value of b. So bringing back our expression, to eliminate, so we have to eliminate a this time around. To eliminate a, we have to substitute x equal to minus 1. So when we impute x as minus 1, the value for a will become 0. That's where we'll be able to get the value for b. So this becomes 6 into bracket minus 1 minus 2 equal to a into bracket minus 1 plus 1 plus b into bracket minus 1 minus 3. We'll close the bracket. 6 times minus 1 gives us minus 6 minus 2 equal to a into bracket minus 1 plus 1, 0, plus b into bracket minus 1 minus 3 gives us minus 4. Minus 6 minus 2 gives us minus 8 equal to a times 0 is 0 plus minus 4 times b gives us minus 4b. So we are left with minus 8 equal to minus 4b. So we'll have to divide both sides by minus 4 to get the value of b. 8 divided by 4 gives us 2 because minus cancel minus, equal to minus 4 cancel minus 4, we have b. So therefore, our b is equals to 2. After we've gotten the value for a and b, thus our final answer becomes 6x minus 2 all over x minus 3 x plus 1 equal to a over x minus 3 plus b over x plus 1. Our answer becomes A we got 4 over x minus 3, and for B we got 2 over x plus 1. So this is the expression for our answer. Now let's move to question number 2. So in example 2, we are given 6x squared plus 5x minus 2 all over x, x minus 1, 2x plus 1. In this case, you will see that our question is already expressed in partial fractions. So we are asked to find the constant a, b, and c. So we'll move straight to the point, which is to look for the LCM. Now the LCM of this expression is x bracket s minus 1, 2x plus 1. So judging from the three values here, it will give us the LCM, which is what we'll have on the left-hand side. So x minus 1, 2x plus 1 divided by the denominator at the left-hand side. If you notice, they are the same. So the same number, whenever they divide each other, we'll have 1. So x minus 1, 2x plus 1 divided by x minus 1, 2x plus 1 is 1. 1 times all we'll have at the numerator, we'll get the same thing, which is 6x squared plus 5x minus 2 equal to x minus 1, 2x plus 1 divided by x. We'll be left with x minus 1, 2x plus 1 multiplied by a. We'll have a bracket x minus 1, 2x plus 1 plus, moving to the b side, x minus 1, 2x plus 1 divided by x minus 1. We'll have x, 2x plus 1 times b gives us bx 2x plus 1 plus, moving to the c side, x minus 1, 2x plus 1 divided by 2x plus 1. We'll be left with x minus 1 times c. We'll have c x bracket x minus 1. So now that we've been able to simplify this using the LCM given above, we'll have to use our substitution method to eliminate some values to get another. Now we're going to use substitution method, but looking at the right hand side, you'll see that we have a, b, and c. So meaning we have to look for a value that will eliminate two of these variables so that we'll be able to get one of it. So meaning if I substitute a value for x in a, if it eliminates a, it should also eliminate another value, which is b, so that I can get my c. Then if I'm to look for b, I'll have to look for a value that will eliminate a and c, and if I'm to look for a, I'll have to look for a value that will eliminate b and c. Now to get a, I will eliminate b and c by substituting s to be 0, because if I put 0 here, which is b times 0, it will give us 0 for every values here. And if I put 0 in c, it will be c times 0, which will give us 0, and it will eliminate every variable here. So this is correct. Now we'll have 6 into 0 square plus 5 into 0 minus 2 equal to a into 0 minus 1, 2 into 0 plus 1 plus b into 0, 2 into 0 plus 1 plus c into 0, 0 minus 1. So this becomes 6 times 0 square. 0 square is 0 times 6. We'll have 0 plus 5 times 0 will give us 0 minus 2 equal to a into gives us minus 1 times 2 times 0 is 0 plus 1. We'll have 1 plus b times 0 gives us 0. 2 times 0 is 0 plus 1. We'll have 1 plus c times 0 gives us 0. 0 minus 1 will have minus 1. Now 0 plus 0 is 0. Minus 2 will have minus 2 equal to a times minus 1 gives us minus a times 1. We still have minus a plus 0 times 1 is 0 plus 0 times minus 1 is 0. So we are left with minus 2 equal to minus a. So minus cancel minus, 2 is equals to a. So therefore, our value for a is 2. So now that we've gotten the value of a, we'll have to get the value of b and c. Now, to get b, which is what we'll have to get now, to get b, we have to eliminate a and c and substitute x to be 1. In the sense that if I put x to be 1 here, 1 minus 1 gives us 0, say a is eliminated. And if I come to the c part and I put 1 in the brackets, 1 minus 1 gives us 0. So c will also be eliminated. So this will actually work to get the value for b. So this becomes 6 in the bracket 1 squared plus 5 into bracket 1 minus 2 equal to a into bracket 1 minus 1, 2 into bracket 1 plus 1 plus b bracket 1, 2 into bracket 1 plus 1 plus c bracket 1 minus 1. So this becomes 1 square will give us 1. 1 times 6 is 6 plus 5 times 1 gives us 5 minus 2 equal to a. 1 minus 1 is 0. 2 times 1 is 2 plus 1, 3 plus b times 1, which is the same as b, bracket 2 times 1 is 2 plus 1, 3 plus c times 1, which is c, bracket 1 minus 1, which is what? 0. Now 6 plus 5 is 11 minus 2 gives us 9 into bracket a times 0 gives us 0 times 3, which is the same as 0, plus 3 times b gives us 3b, plus c times 0 gives us 0. So we are left with 9 equal to 3b. So when we divide both sides by 3, 3 here 1, 3 in 9, we have 3 equals to b. So therefore, our b is equal to 3. I've gotten the value of a and now b. We move forward to get the value of c. So we're working with the same expression. Here, now to get c, we have to eliminate a and b by substituting s to be equals to minus half. So that way, if we put minus half to the value of x, our a and b becomes 0. So let's impute the value for x as minus half in the expression. So we'll have 6 into bracket minus half square plus 5 into bracket minus half minus 2 equal to a into bracket minus half minus 1 bracket 2 into minus half plus 1 plus b into bracket minus half bracket 2 into bracket minus half plus 1 plus c into bracket minus half, then minus half minus 1. So expressing further, minus 1 over 2 square gives us 1 over 4. So we'll multiply that by 6. We'll have 6 into brackets 1 over 4 plus 5 times minus half gives us minus 5 over 2 minus 2 equal to a into bracket minus 1 over 2 minus 1 gives us minus 3 over 2 brackets 2 here 1, 2 here 1. So we have minus 1 plus 1, which is 0, plus b into bracket minus 1 over 2. Then we'll have 2 here 1, 2 here 1. Minus 1 plus 1 gives us 0, plus c into brackets minus 1 over 2. bracket minus 1 over 2 minus 1 gives us minus 3 over 2. Now, for this expression, 2 here, 3, 2 in 4, we have 2. So we are left with 3 over 2 minus 5 over 2 minus 2 equals to a times minus 3 over 2 times 0 gives us 0, plus b times minus half times 0 gives us 0, plus c times minus 1 over 2 times minus 3 over 2. We'll multiply the numerators first. Minus 1 times minus 3 gives us 3 over 2 times 2 gives us 4. Moving to the left hand side, we have to look for the LCM of the expression. So the LCM of this expression is 2. 2 divided by 2 gives us 1. 1 times 3 will have 3 minus 2 divided by 2 gives us 1. 1 times 5 gives us 5 minus 2 divided by 1 gives us 2 times 2 will have 4 equal to 0 plus 0 is gone. Then we'll have c times 3 over 4, which will give us 3c over 4. So our expression becomes 3 minus 5 will have minus 2. Minus 2 minus 4 will give us minus 6 over 2 equal to 3c over 4. So when we cross multiply, 2 times 3c gives us 6c equal to minus 6 times 4 gives us minus 24. So I'll divide through by 6. 6 cancels 6. We'll have 1. 1 times c gives us c equal to 6 here 1. 6 in 24 will have 4. So we'll have minus 4. So now that we've gotten the value for a, b, and c, we'll substitute the value for these constants in the expression. So our partial fractions become, we have equal to, for the value of a, we'll have 2 over x, plus for the value of b, we'll have 3 over x minus 1, plus for the value of c, we'll have minus 4 over 2x plus 1. So therefore, the answer is 2 over x plus 3 over x minus 1 minus 4 over 2x plus 1. So these are the answers for the expression given in this question. Thank you for joining us for today's section. See you in our next class. Bye.